Yeah, thanks for such a fantastic turnout. And I've got to say that this is one of the probably most exciting projects that I've ever worked on, and I've done some fantastic field programs. Conoco had a habit of sending me into some strange places like Somalia and New Guinea and Soviet Georgia and the backwoods of Venezuela, while we were always very up at the upstream end of upstream, deciding whether we wanted to get into plays. So there's a lot of people that were involved in this, and there's a table back there of a bunch of people from the Kurdistan team see which is the pointer, for dynamic upstream E&P. And I'll get to them in a minute. Some other people here from Conoco. Terry Begans was with me in Soviet Georgia. Henry Lieberman, who many of you might know, and I, as well as Janice Christ, did fieldwork in Vietnam. And I was pretty much on my own in Somalia, for obvious reasons. Anyway, given the interest in the news and the publicity that this has had over the last few years, what I'd like to do is kind of depart from the purely technical point of view and talk a little bit about the play that's been unfolding for the last 8 or 10 years in Kurdistan, and go back to review a little bit of the history of how we got where we are here. I think a lot of you experienced the opening of the FSU, and this was very similar to that in the sense that previously essentially closed territory to Western companies suddenly became open because of political reasons. And of course it's politically tempestuous right now. And who ever heard of Kurdistan until the last few years? So we'll talk a little bit about who they are, how they got where they are for 5 or 10 minutes, and then we'll start to talk about the oil and gas fields, a little bit about the history of the oil and gas fields, the big picture. After all, this is part of the Arabian Plate, the stratigraphy and source rocks. It's easier to pick a unit that does not participate in a petroleum system than it is to enumerate the ones that do. And then we'll talk about the structural geology, which is the primary interest from my point of view, and it's probably the biggest rock in terms of success, geoscience success in the Kurdistan area, because it's a thin-skinned fold and thrust belt with some of its own peculiarities. And then finally we'll stop with some closing thoughts. Here's a couple of pictures. This will be peppered with slides that I've taken over the last few years. This is one of the refugee camps from the conflict in Syria. It's about 10 miles away from one of our field areas near the city of Dohuk, which you might have heard if you've been paying attention to the news. Dohuk was the city that collected a lot of the people fleeing ISIS. Well, even before ISIS popped up in the Iraqi side, Kurdish primarily refugees were fleeing over to Dohuk, and this is one of the refugee camps that they were placed in. Who are we? Dynamic Upstream E&P Consultants is a consulting firm headquartered just a little ways from here in the West Chase area. It's about maybe 30 plus, sometimes it's a few more, and sometimes it's a few less consultants that are, some of them are full-time to the company, some of them are virtual, and some are part-time. I'm virtual and part-time. There's a table back here of a number of the folks that are involved in this project. Many of them have actually worked in various aspects of the Kurdistan project, and I'll show you in a minute what dynamic E&P has been doing. So there's where Van Odell is. He's surrounded by Frank Crico and Ken Mallon and Tom Uphoff, who have all contributed various aspects to this. Yeah, Janet Combs is one of our resources. And I'd also like to point out Nicola. Nicola works for, well, it was Task. Is it still Task? Yeah, and they've done a lot of the FMI work for many of the wells there. So there are a number of people who have chipped in and worked with Dynamic E&P who aren't really part of the core members of the company. It's a full upstream services kind of consulting service. So what Joe Studlick, who's the manager, does is collects whoever needs to work on a project and plugs them in. So it's very adaptable and very nimble. There's the URL for it if you're interested. I don't mean to do this as an ad for the company, as an advertisement, but rather to kind of develop our street creds for this. Why are we qualified to talk about Kurdistan? Well, I'm personally qualified because I've been there 6 times doing field work for on the order of 4 or 5 different clients, all the way from fracture studies to structure studies in the field, doing cross sections back at home, and teaching field training courses for the Kurdistan ministry. So all told, I've probably spent 8 or 10 months on the ground there since about 2010. Now, what has the team been doing? Oh, I'd like to also mention that I'd like to devote this talk to one of our fallen comrades, Tim Vevgenets, who we just lost last year to glioblastoma. He was in the field with us doing the fracture studies and pioneering some of the work with LIDAR detection. Here he is with one of the instruments, collecting fracture data, statistical numbers. So anyway, Tim was one of the people. He was actually a faculty member at Colorado Western University. And so just an example of how we pull in the people we need to accomplish the projects. So, Dynamic's been involved in Kurdistan since about 2009, and it started out with the Shaikan discovery doing reserve certification and various petrophysical and well studies. And along with that, there's been some seismic interpretation and back and forth with supporting some of the earlier operators in Kurdistan. The majors were not the first ones to run in, and we'll talk about why in just a minute. Additionally, fracture studies, both based in core, like I said, the LIDAR studies, and then on the outcrop, petrographic type things. Of course, you do the LIDAR to get statistics on the families of fractures that you've determined in the field. And of course, most of that work, and of course from FMI, I guess I don't have downhole image. There's the borehole imaging. All of those are integrated into the idea of building a fracture model for reservoir studies, because this is the Arabian Plate, and most of the reservoirs are fractured carbonates, as we'll see in a little while. And then finally, structure studies, which has been my bailiwick, going all the way to try to balance cross sections and put the wells that the various operators have been drilling into a very live and very complicated thrust belt into some kind of context. So I still get calls from our current client who's drilling and say, "We don't know where we are. What does your cross section say? Here's the FMI that Nicola sent," and all lump it into, in this particular case, Lithotech, to build restorable cross sections to make sense out of surface geology, seismic data, the downhole data, and whatever we can scrap together. Okay, so that's why we're here, and why probably more than anybody in Houston. There are some operators here, Marathon, for example. We've seen a little bit more than most of them because we've seen several of the different blocks and quite a few of the wells. Unfortunately, I'm not able to show much seismic. There are a couple of snippets of seismic in here because that's very sensitive, but I will try to talk about the structure in the context of seismically influenced interpretations. All right, well, a little about Kurdistan. Who are the Kurds and what's all this about? Here's a map that you can get off the internet. Basically, it shows northern Iraq, Syria, eastern Turkey, Iran, and some of the other minority population type countries in the region, Azerbaijan, Armenia, and Georgia. Colored in orange on there is the homeland for the Kurdish populations. Well, the Kurds are a separate ethnic population, just like Armenians or just like Georgians. It's just that here in the United States, we never heard very much about them because we didn't get much in the way of immigrants to come to the United States. They are not Semitic, they are not Arabic, they are not Turkish, they're Kurdish. And unfortunately, as a result of the vagaries of history, they never ended up with their own nation. They all ended up split up between several nations here. And the main populations are in northeastern Syria. Of course, there's a large population. In fact, 1/5 of the Turkish population is Kurdish. And then in northern Iraq, and there are some populations over in Iran. And ever since after World War I, when this area was split up into countries, the various Kurds have always inspired to have their own homeland, but they've always been frustrated in that. And their experience in each one of these countries has ended up being a little bit different. As a result of events in history since about 1970, the Kurds in Iraq have, little by little, gained a certain measure of their own independence. And they have a capital at Erbil, or Erbil. It just grates on me when I hear the news say Erbil. It's Erbil, not Erbil, which is a town in northern Iraq, right there where the star is. It's centered on a citadel, which has been the site of human habitation since about 3000 BC. Part of the old civilizations that predate the Assyrians, etc. We'll go into a little bit of that. They're a distinctive population. Here I am in fatter days, having tea in the afternoon with some of the old boys in there. Is this in focus for you guys? Yeah, it is. Okay, because it's a little hard at the angle here. Why don't you move somewhere where you guys can see? Yeah, can somebody control the lights back there?
We have to have the lights on for the filming to go on YouTube, sorry.
Okay. Well. Anyway, the older guys have distinctive dress. They have these overall-like overhaul, usually olive green type garments with a sash around the waist and a distinctive turban. And here I am having tea with them in one afternoon. This is the area, this blue thing that I've just slidden in here, is the area that is now called the Kurdistan Regional Government, or under their somewhat autonomous control. But there are Kurds in Turkey who have a little bit different relationship to the rest of the world. You may have heard of the PKK, the Kurdish Workers' Party in Turkey, who are counted as a terrorist group by everybody, including Turkey and including Iraq and including the EU and us and even Syria. They have their own flag, which is that little flag right there. I don't want to slight the Turks. Their history has been one of trying to accommodate themselves within the remnants of the Ottoman Empire, which we now call the Republic of Turkey. A good number of them actually are in Iraqi Kurdistan, have occupied areas to the north here, and have somewhat of an unsettled, hands-off relationship with the Iraqi Kurds, because they have used Iraq as a refuge from Turkish reprisals, shall we say. And I've sat on mountains here in northern Kurdistan, and I've seen the Turkish jets come in and bomb. And we've actually had to deal with these guys to get through checkpoints. You would look like one. You would look like one. They have young ladies at their checkpoints. Kalashnikovs and the whole bit. So it's quite an experience. Anyway, so a brief history of the region. Basically, it's a long-standing crossroads with a well-developed Neanderthal culture. In fact, there's a national park called Shanidar Caves where in the 1930s there were quite a few Neanderthal skeletons excavated, and they're now in, I think they're in German museums. And there's a long-standing, there are lots of Neolithic cultures. And a lot of the wells drill through, when they first start their drilling, they have to drill through karsted carbonates. And they often hit caves. And I tell my clients, keep drilling. Don't go in there. You don't know what you're going to find. You might get completely shut down because you'll run into some of these relatively important artifacts. Of course, they were part of the Akkadian and Assyrian empires up until about 600 BC. That's when, during that period when Erbil was actually founded. It was developed as part of the cult of Ishtar, which is kind of a Dionysus version in the Assyrian culture. There's an image of her. At that time, it went into the Babylonian Empire until about 332 BC, when the area was conquered by Alexander, which was basically their first contact with the Western world. It became a Roman province of Assyria and was passed back and forth with the Persian empires for a long period of time until in about 600 AD, the Arab conquest arrived and converted most Kurds to Islam. And since then, it's been part of various forms of the caliphate and ruled by the Turkish Empire, the Ottoman Empire, until the First World War. And in the 20th century, we start to get the history that's important for the situation right now. Of course, after World War I, with the demise of the Ottoman Empire, it was administered by the British. And there was a rolling revolt, Kurdish revolt, led by the Barzani clan, who was an extremely important family in the history of modern Kurdistan. In 1931, pretty much made a pact with the British, but still demanded a separate Kurdish province. You'll remember that after World War I, this region was split up by the French and the British into these modern states of Syria, Iraq, and what amounted to being Turkey, and the frontier with Iran was settled. But they did that in Paris, of course, and they completely ignored the Kurds and split them up into separate countries. After World War II, well, during World War II, with everybody else being more or less or occupied elsewhere, they started to develop something of their own autonomy. And they organized themselves into a couple of resistance groups that persist to today. After modern Iraq, after the war, modern Iraq took control again until there was another rebellion in the 60s and 70s. And at this time, as a peace kind of bone, they were allowed to develop what was called the Kurdish Autonomous Region, with a certain amount of nominal self-rule. But of course, this was, beginning to be the time of Saddam Hussein, and it was basically just a Ba'athist, shall we say, club or province or sub-party in the north, but it was all still controlled from Baghdad. The trouble really began in 1973 with the Iran-Iraq War, when the CIA funded Kurdish rebels versus Baghdad in the Iran-Iraq situation. Of course, it started in 73, and the Iran-Iraq War really blossomed after the 1979 takeover of our embassy in Tehran. And you'll probably remember that in the 1980s, Iran and Iraq killed probably, I don't know, Norm, you know some of the history, hundreds of thousands of people on both sides, using poison gas and all kinds of techniques. Well, of course, the U.S. sided with Iraq, with Saddam Hussein during that time, because of the antipathy with Iran, and funded the Kurds to fight against the other governments. I guess I've got the wrong date here. This should be 83 and 84. The Algiers Agreement concluded the Iran-Iraq wars, but it left the Kurds completely unsupported. This is the first time the U.S. sort of abandoned them and left them alone. Didn't support them. And after that, they had to forge a guerrilla war to fight against Saddam Hussein's basically Arabization of most of the Kurdish territories in northern Iraq. What Saddam Hussein was doing was importing Arab people to take over cities like Kirkuk and Mosul. And of course, what he wanted was to expand the oil and gas holdings within the central government, which had trouble operating in the north. So finally, over the period of time, by the 1980s, the Al-Anfal campaign had killed something like 200,000 Kurds, using the same sort of methods that were applied in the Iran-Iraq war, including poison gas and bombing of just random villages. Now, since 1990 or so, after Desert Storm, the Kurdish populations have developed a certain measure of their own independence, because you'll probably recall that at the conclusion of Desert Storm, the United Nations, under U.S. auspices, imposed a no-fly policy for all of Iraqi forces. And essentially that was the only leverage that Saddam Hussein had over the Kurds. On the ground, he was stymied by not only terrain and things like that, but the Peshmerga are very formidable, very formidable force. They weren't very well organized at that time. They had these two resistance groups, the PDK and the PUK, and they have evolved since 1991 into political parties as the KRG has essentially developed its own government out of this autonomous region. They've evolved into something of a actually pluralistic, quasi-democratic government. And you might remember some of the names that are involved in there. With Iraqi freedom, the Peshmerga were important in that effort, and of course fought on the American side. The PUK contributed, the guy who recently deceased became the president of Iraq, Jalal Talabani. When the new government was instituted, they separated different parts of the government, the president and the prime minister, I think one other office, were split between Kurds, Sunnis, and Shia. And the Kurds got to be the president, so that was foretold. Meanwhile, the Kurdistan regional government developed its own president, its own representative government in Erbil, and that was, at the beginning, was headed by Masoud Barzani, who was the grandson of the god, the Barzani, that started all of the post-World War I resistance in the 1930s. And he has passed the position of prime minister on to his nephew, who's now the current prime minister. On the other hand, you know, the experience in the other countries has been quite different. The PKK have been an underground guerrilla group, essentially have never gotten to have their own representation in Turkish government. And the situation right now is one of a, shall we say, tenuous truce between the Kurdish rebels and the central Turkish government. The leader of the Turkish rebels is Mahmoud, I forget his name just offhand, but he's in jail in Istanbul, and he's been negotiating with the Turkish government. And right now there's a truce, no more flights over to bomb him. But all of the armed PKK troops, including the ladies and their men and everything, are now in Kurdistan, Iraqi Kurdistan, spread out along the border, some of them facing into Iran and some of them facing into Turkey. And they have fairly sophisticated setups. They have a capital that's over on the east, close to the Iranian border. They have hospitals, they have their own government, and then they have outposts of fighters who are stuck in backwoods positions where they're very difficult to dislodge. So that's an evolving situation. Okay, well, Kurdistan is a land of minorities. I mentioned that most of them are Islamic, but there are large populations of Christians and other religions that you may have heard about. And in fact, here's a monastery that was in a city that were featured on CNN a couple weeks ago in one of their pieces on what ISIS has been doing relative to the Christians. So by the way, if I go back to that screen, didn't come out very well. But there's a line here, a red line that I've put, and this is basically the advance of ISIS, which had come in from the Syrian Revolution, or Syrian Civil War, and basically swept in a big arc here, spreading out like that, in a drive toward Baghdad. And they were, of course, stopped down here, very close to Baiji refinery. And now the central Iraqi government, with Iranian Shia support, that's a Shia-Sunni thing, have been retaking cities down here, want to get Anbar province. They recently reacquired Tikrit. And of course, this interface brought ISIS into conflict with the Kurds. Many of the Kurdish Christians live right along that front, as well as the Yazidi that you might have heard. So going back to this, Al-Qush is about 5 miles away from that line and received a lot of Christian refugees. Here's a mural painted on one of the houses with showing Jesus, and of course some of the burial grounds for Christians. There are several Christian monasteries. This one happens to be a Chaldean Catholic one. It's uphill from Al-Qush. And any one of us who grew up as Catholics, Terry, could go and see Mass in their churches. They recognize Rome, but we would recognize it as a pre-Vatican II Mass in Latin and in Arabic. Other minorities, the Yazidi you may have heard of. I had never really known anything about Yazidi till I came to this part of the world, and most of the outside world doesn't. There are a few who have immigrated to Germany. They are an amalgamation of a little bit of Muslim, a little bit of Zoroastrianism, a little bit of Jewish, and they have their effective religious capital at a place called Lalesh, which is an interesting place sitting on the west side of Gulf Keystone's discovery at Shaikan, sitting right on top of the Anticline. You can pick them out because they always have these conical type pyramidal buildings, or they have a sun sign on the front of some of their temples. And if you're perfectly welcome to go and visit, they have a lot of pagan kind of symbols in it. There's a snake on the front of one of the temples. This is in Lalesh. And their patron saint, if you like, is Sheikh Abd Idi Musafir, who died in the 12th century, who basically organized a disparate number of religious groups into an organized religion. And there are many others. There are Turkmen in Kurdistan. There are some other religious groups that I can't remember the name of, but I collected some of them in that abstract. So this modern state of Kurdistan, if you want to call it that, is something of a melting pot, like we would recognize, of course, with Middle Eastern overtones. And they're evolving toward, I don't know how totally democratic it is, but they are evolving toward at least a pluralistic society with a democratic representation, if they can survive what's going on now. All right, so now the petroleum industry, that's the background. The petroleum industry that is actually developing right now is developing because that KRG started to grow large enough that in 2002, several years after the no-fly zone, they started to independently license blocks separately from the central government in Baghdad. Baghdad does not recognize these licenses, but they are very attractive to the industry because they're PSCs, PSAs rather than service agreements. So they function as if the companies can actually book reserves, just like any other PSC.
Well, because of the risk originally.
Well, because of the risk, originally in 2002, one of the pioneers in this was Granath, Tony Hayward's company, even though Tony wasn't the chairman at the time. Granath, a Turkish company, had the connections to the KRG to advise them on the structure of some of these PSCs and PSAs.
So they were about the largest company.
So they were about the largest company that went in at that time. Because of the the political risk and the military risk and the security risk and almost every other risk, it took several years before the majors started to come in. And these smaller companies made most of the early discoveries. And I've got to accept Marathon as being one of the very first majors. Do we have anybody from Marathon here? You work the project? You do. They were one of the very first big companies to actually take a block in partnership with some of the smaller ones. And I'll show you a acreage map in just a moment. Now, earlier on, by the 1970s, by reason of the Iraqi government, there were several earlier fields, like ones you might have heard of, the famous Kirkuk, a bone of contention right now between not only Baghdad and Erbil, but also with ISIS. And one of the places where the Kurds are literally standing off ISIS across the boundary in those territories. I don't know what Kirkuk's reserves are, but you'll see how big it is in a minute. Now, back then, the initial production was from the Tertiary and Cretaceous, because most of these early wells were fairly shallow. And one of the geological risks that people were worried about before they took these PSCs was whether those reservoirs were going to be productive enough to be economic. However, in the last few years, more recent discoveries are in the Jurassic and even the Triassic. And as we go deeper in the section, the oil gets better and better. So some of these shallow fields in the Tertiary and Cretaceous are fairly heavy oil in the teens and low 20s. The stuff in the Triassic is good stuff, 43, 45 API. Of course, the carbonate reservoirs, we still have H2S problems. It's, handling the crude, but it's really good stuff. Now, we were the reserve certification group for GKP, Gulf Keystone Petroleum in London, independent reserve certification. And when we did it, in 2009 or so, right after the discovery, over 10 billion barrels in one field. And we'll look at the stratigraphic column in a second. So here's the leasing situation that Tom Upoff, I think, has been keeping. Is it you, Tom, been keeping track of these? Trying to keep track because it changes all the time. Basically, it looks kind of grayish to me here. This gray area and the light blue is the area that is claimed by the KRG and divided up into blocks. So they originally divided it up, big structure in each block. They just drew lines around each block and leased the structures. Most of them have surface expression, particularly when you get back to the northeast of the thrust front, which I'll show you in a minute. Here's Kirkuk. The dark arrows are pointing at fields that were known at the time the KRG started to do the licenses. So there was one down here that was just off the Iranian border that I think was like 1908. But here's Kirkuk, here's Tak Tak, Jamal, then a couple of them down here. You can see they're all near the boundary with Iraq, and the city of Kirkuk is right there. That's one of the cities that was the focus of Saddam Hussein's Arabization program. And it's now a bone of contention because it's primarily a Kurdish city. Mosul is up here. Now the dots on here were wells that were drilled before the KRG started to license blocks. So you can see that there were all kinds of indications that there was big oil in the region. Kirkuk, of course, has been producing for years and years. It's got like 115 wells in it. And I don't know what the cumulative production is, but it's amazing. Open areas are shown in the light blue, and that changes all the time. Some of these are high in the Zagros range and not really very productive, or expected to be very productive. But we don't know, because some of the Tethyan oceanic fragments are actually thrust over the productive stratigraphy. And that's also the case up in here. I'll get in a little more into geology, in a little bit.
Infrastructure situation.
So, infrastructure situation is dominated by Iraq. And the arrangement of the first constitution left behind by the Americans was that all the production from Kurdistan was supposed to go into the pipelines and be marketed by the federal government in Baghdad, and that they would then turn around and pay the Kurds. Can you guess how that worked out? Didn't work out so well. So, especially with newer discoveries, all of this volume of oil, of course, can't stay where it is. It's been burning to get out. Right recently, on this slide, I put a circle around some of the very first fields. Shaikan, which we did that certification for, was one of the first discoveries and the first fields to come on production. They built a pipeline that now is connected into a pipeline that goes into Turkey, that Baghdad's not too happy about, because they can't, of course, control it. And then oil eventually gets to the pipeline in Turkey and gets marketed to the rest of the world through Ceyhan, which of course was the seaport, the export port that was born by the opening of the Soviet Union, the FSU, and the oil coming from the Caspian regions, primarily Azerbaijan, actually now gets marketed out through there. So you can see how complicated the political situation is. Not only are they marketing through this territory, they're marketing into Turkey through other Kurdish territory, with a simmering conflict within the Turkish realm. So, this is the flag for the Kurdistan regional government. You can see that it has Islamic colors, but it has that sun sign for the Yazidi, and the different colors relate to the different minorities that contribute to the Kurdish population. All right, so the petroleum geology, let's just look at a summary to get a first look at what we're going to see. By the 1970s, these tertiary and Cretaceous reservoirs were the ones that were developed at most. No seismic, or very little seismic. I think Norm has probably seen all the seismic when he worked over in Iraq that there ever was until the last couple of years. So all of these were very much like the Zagros fields in Iran. They were drilled on anticlines. Anticlinal theory. Get on top and drill a hole. And they were completed in the first ones, that first reservoirs, or the first pay that they found. Of course, all that was interrupted by wars in the 1980s and 90s. Like I said, the licensing started in 2002. First wells and discoveries came in 2006, and by 2009, like I say, GKP and Shaikan were beginning, and that's when we got involved. Lots, you could tell from that operational map that there's a lot of fields that have come in since that are in various stages of delineation. Very, very few reliable quotations on how much oil, and you'll see why when I show you a stratigraphic column in a minute. But it's generally gassier to the south, because as you go toward the south, you're getting deeper and deeper into the foreland basin for the bona fide Zagros fold belt. As you get farther up to the northwest, although they call it the Zagros, it's really the frontal part of the Taurus fold belt, and its geologic history is a little bit different. It's a little bit strike slippy, a little transpressional, and although the foreland basin is quite well developed, it's only depressed most of the reservoir, most of the source rocks into the oil window. Like I say, many of the fields are 10 billion barrels in place and more. reliable figures are not available. And as things have gone on, the deeper targets turned out to have the best oil. Heavy oil in the Cretaceous and Jurassic, like I say, 40 plus in many of the Triassic reservoirs. I think the Jurassic is going to be quite variable as it starts to fill in. And is the Permian coming? There's putative evidence that there are Paleozoic source rocks that haven't even been tapped. And there's plenty of surface evidence of seeps. This is some very famous seeps with these things that look like Pahoehoe lava. Here's one on a road cut through the end of Shaikan Anticline with, in the summertime, oil that just drips right out of the fractures. And in the wintertime, when it's a little cold, it gets sticky and freezes up. Here's a co-author standing in front of it. This is actually an oil seep in the Eocene limestones that are probably 1,000 meters or more above, stratigraphically above the actual reservoirs. So there's plenty of oil around. You can see it comes out on the ground in lots of different places. All right, this is why. Here's a stratigraphic column that usually you'll see the stratigraphic column that only goes down to the Permian here. I have stuck in a pre-Permian section for all of the Paleozoic just to get it completed. Cenozoic, Cretaceous, Jurassic, Triassic, Permian, and then the rest of the Paleozoic. And down below here is a crystalline basement that we don't really see, but it is exposed to the north in Turkey, where it's actually been thrust up in the central part of the fold and thrust belt. I'll talk a little bit about those relations. It's a bit different from the Zagros. In the Zagros, you never see the crystalline basement. Here you see exotic pieces of tethys, like ophiolites and pieces of island arcs that have been thrust on the east side of the plate.
Reservoirs in red.
Reservoirs in red, source rocks in green. After all, this is the Arabian Plate. Some of these are notional. The three really proven petroleum systems are the ones with the exclamation points next to it. And that doesn't really do it a lot of justice because we'd have to expand the chart to actually find out that these petroleum systems in the Jurassic are counted as 3 and 4 separate systems by people with 3 or 4 different horizons that are productive. The same is true of the lower Cretaceous one. And then here's the Permian one, or the Triassic one, in this Curachina limestone section, which is a variegated limestone anhydrite carbonaceous shale section that we don't even know the thickness of yet. So all of these different red dots are horizons that have in various places been encountered as reservoirs. The trick, or the, let's say let's just call it the trick, is that this is the Arabian Plate stratigraphy, and each one of these units is far more complicated than it would be, say, in the Rocky Mountains. There's a lot of very small scale facies relationships within each one of these units, so that when you drill a well in one structure and you get pay, for example, in this reservoir right next to the source rock, you can go down strike on the same structure or in a neighboring structure and it won't be pay. So predicting where your targets are when you drill the wells is proving to be quite tricky. And some fields turn out to have lots of good pay up here. Some fields have pay down here, and it's almost, pardon the expression, a crapshoot. And that's just a function of the fact that the geologic history of the Arabian Plate is almost unique. Of course, we know the situation down south in Saudi Arabia, where they have even Paleozoic and even late Precambrian potential reservoirs. Here we don't see anything older than Ordovician, which is thrust up in the back of the fold and thrust belt right next to the Turkish border, where it's been brought up and it's sitting on top of the Cretaceous in that position. We never see anything older until you get over into Turkey, where there are indications that perhaps there are Cambrian, maybe some Precambrian sediments, but there is crystalline basement that's part of the Arabian Plate.
All that was created.
All that was created way back in the Paleozoic. In this part of the world, we don't see some of the stuff that makes the area to the south in Kuwait and Saudi Arabia so productive. For example, there is no Hormuz salt. And although we have anhydrites and evaporitic sections, we don't have anything that really is anything like a diapiric situation. But we have a extensional margin that was developed at the Permo-Triassic time, which basically rifted off a good part of the eastern part of the plate, is the so-called Sumerian terrain, which drifted off into Tethys. But that was the last event until the convergence really started up here in the Neogene. Actually started in the Cretaceous and then culminated in the Neogene. So we have a 200 million year old passive margin in between those two events, which is accumulating epicratonic basins, varying thicknesses. It's a land of very detailed sequence stratigraphy, and the Arabian Plate, of course, is a site of very sophisticated stratigraphic studies. The seas come in, the seas go out. It's been doing it for a long time. Meanwhile, the plate has been riding over, the asthenosphere, and it's been going up and down a little bit, so it has very complicated, subtle tectonic relationships. There are a lot of high blocks in the middle of the Arabian Plate that have section thinning on top, or maybe they get depressed for a while. It's like some very subtle pistons going on. And so the stratigraphy of the Arabian Plate is very sophisticated. The structure is just the opposite. So most of the structure in the Arabian Plate is relatively simple. The biggest thing that they have to deal with, for example, at Ghavar down in Saudi Arabia, is a recurrent high block. And then finally, during the Zagros collision, it actually pops up like a Rocky Mountain foreland uplift. And it's only the full length of Louisiana, from New Orleans to Arkansas, divided into 3 or 4 segments, different units that Aramco develops. So the structural studies in the Arabian Plate are not terribly sophisticated. I've had some Kuwaiti guys in some of my courses, and they get completely baffled when we pull out the thin-skin fold and thrust belt stuff, and they tear their hair out. Some of them even leave the room because it's all too hard. But as soon as you get north of Kuwait and into this territory, that's what they have to deal with. So one of the themes at the end of this talk, I'm going to talk a little bit about the structural complexity and make a plea for anybody who's got any influence to try to help that situation out.
Okay, so the collision actually starts.
Okay, so the collision actually starts. There are a number of individual blocks out there in that Tethys Ocean in between this nice Arabian Plate and Eurasia. And the people who talk about the tectonics talk about the collision of the Arabian Plate with Eurasia, as if Eurasia is also another simple tectonic block, and it's not, because central Iran through Turkey, all the way through the whole Tethyan realm, there are all kinds of continental fragments, ocean fragments, island arc fragments, all sorts of pieces of oceanic plateaus that are all viced in that collision. So a good part of the stratigraphy here, the complexity, this subtle complexity, up until about the Cretaceous time, is the subtle interaction of the plate with a lot of those different elements over time, until finally, in the Cretaceous, some places on the eastern side of the plate acquired an ophiolitic abduction. The first evidence of tectonic compression is oceanic crust abducted onto the Arabian Plate in the Cretaceous. Cretaceous crust and Cretaceous abduction. Very young, and that's why it could go up rather than down. So that's part of the complexity. And then the actual closure of Tethys didn't occur until the Neogene here. And all of these sections up in here, the famous Fars Formation and the Bakhtiari Formation, are elements of the foreland basin, at least in this part of the plate. And they bury the fold and thrust belt, which is still active and still moving to the south, and seems simple because they haven't been exhumed out of their foreland basin cover yet.
So here's the current plate.
Okay, so here's the current plate situation. The Arabian plate separated from the rest of the African plate with the opening of the Red Sea. It's translating north and colliding in with the Eurasian fragments, I'll call them, across the Dead Sea Transform and the Zagros Fold Belt and the Makran. And so you can see some of the famous areas that are well represented in the literature. We're up in here, where the Zagros, which comes into eastern Iraq, actually makes that bend around the corner and starts to interact with a different set of tectonics in southern Turkey. And that's where most of our work has been. I mean, we've done some cross sections and things for clients all the way down the belt. You can see subtle differences between those different histories. Here's a representation of the situation in Anisian time, 240 million years ago, when the Arabian plate was actually an integral part of the African plate. You can see the Tethyan Ocean being created. This is when that passive margin was really opened in Triassic time. And it sort of represents some of these fragments in the Tethyan realm. Eurasia as a continental block is up here. So there's a lot of things going on in this Tethyan realm that affected the stratigraphy. And there's a lot of defects in the Arabian plate. These are gravity maps here of the whole plate, and then this one blown up for the Kurdistan area. Free air gravity maps that show a complex relationship of very subtle highs and lows in the interior of the plate that accumulated various thicknesses of section and then were reactivated and uplifted during the collision. So if we look at a typical petroleum systems chart, this one was drawn early on in the Shaikan exploration before they even discovered the Triassic reservoir. Shaikan anticline, Jurassic, Cretaceous, and then getting into the tertiary. The first row there are the source rocks. And then they've got their reservoir rocks. They discounted some of the tertiary things because they thought they were too shallow, and indeed they turned out not to be productive. Of course, overburden and everything. Trap formation is a function of the actual collision in the Neogene, primarily in the Miocene, and you can see that timing corresponds to the deposition of that famous Fars Formation, which is an Iranian name or Persian name, and the Bakhtiari on top of it, which is a limestone pebble conglomerate with pebbles like this. And then so here, the maturation is a function of the progressive collision and the dipping of that edge of the plate into the foreland basin and the accumulation of that section, which drove the source rocks into the oil window. So it's a very happy sequence of events. This diagram was drawn for a nearby well, Bajel 1, which is in the foreland basin itself. I've kind of marked the three positions of the primary source rocks on here in green, and you can follow them down into the oil window, which is this yellow, and then the gas window. So here's the three of them going into the petroleum windows. And this dive off at the end here at about 15 to 17 million years is the actual rollover and acceleration of subsidence in the foreland basin as the Arabian plate gets bent down. And the folding is sitting in that situation right there. So you can see it's a happy situation in terms of petroleum systems. So when you've got so many reservoirs and you've got so many source rocks, it's almost impossible not to get one of them in the right sequence. And this is from a recent paper in the APG just earlier this year by English et al. From Petro-Celtic. They have first comprehensive publication of source rock situations in the region. This is northern Iraq, or this is the northern part of Kurdistan, and it rolls around like this and going down here. So here's the Iranian border. And the thrust front, which I'll show you, is right in here. There's Turkey, Syria, and Iran going up like so. And so this, for the Jurassic petroleum system, you can see that they've got the entire area, except when we get down to here, is in the oil window. And then it goes into a gas plus condensate or gas plus liquids, and then finally into a dry gas window way down here in the southeast. And that's a function of the fact that as you go this direction, down toward the Arabian Gulf or Persian Gulf, depending on your polarity, you're getting deeper and deeper into the Zagros collision zone and the Zagros foreland basin. The actual reason for the Arabian Gulf is that it is the foreland basin that hasn't been completely filled. It's been flooded by the Indian Ocean and progressively being filled in up at its northern part by Tigris and Euphrates delivery of sediment into the system. If you look at the Triassic system now, you can see that basically you've got an oil window again up here in the northern part, the Turkish-facing part of the belt, and then go into a wet gas and condensate area, and then finally a gas area down here. So that's the reason most of these fields down here are gas right now. There are a few oil fields that are remnant from the earlier part of the migration, but the dominant reserves are in gas. So let's look at a typical field, Tac-Tac, discovered in 1958. It's operated by Granath, and Shamaran is a partner by reason of a partnership called the General Exploration Partners, but that's neither here nor there. They've gone in and redeveloped it. They licensed it when the early discoveries were originally in this part of the section. This Pelaspi is a very important unit. It's Eocene limestone, and it's the very last pre-foreland basin, very last platform unit before the collision. And after that, you go from limestones and dolomites, shallow water limestones and dolomites to, depending on where you are in the belt, the fars is usually described as siltstones and gypsums and shales and everything, and then that gets progressively coarser till you get into those carbonate conglomerates as the fold and thrust belt inches onto the craton and sheds progressively coarser material into the foreland basin. If you get up close to the Turkish border, as we did with our fieldwork, you find out that this lower fars is replaced by, and we're trying to get some dates on it, is replaced by a polymic pebble conglomerate that contains basement pebbles derived from Turkey. So those were being shed onto the fold and thrust belt or off of it before it actually got down into Iraq, when it was still a Turkish fold belt. So this is very, very classic coarsening upward foreland basin section, and you can almost pick the unroofing section. You know, you get basement pebbles, and then finally the frontal part as it's coming up is shedding carbonates. And as I'll show a little later, right on top of that, in the Pleistocene, is a pediment. I don't know, people who live in the Rocky Mountains or did their field work in the Rocky Mountains will recognize a pediment as an erosional terrace veneered by colloids, conglomerate. And they are a cold climate feature, so you could date this as a Pleistocene feature. And I've been in a couple places where the tip of it is folded. So that pediment has started to be uplifted with some of the frontal part of the fold and thrust belt. All right, so getting back to Tac-Tac. Here's some statistics on it. The 2P is 607 million barrels. That's gone up by reason of discoveries in the deeper reservoirs. Here they've discovered various production out of various horizons in the uppermost Cretaceous and going down into the middle of the upper Cretaceous. So they've added this production as the field has matured. So they've expanded to Jurassic, and they're trying to get to the Triassic. When their neighbors discovered it, try it out. So source rocks are considered to be the lower Cretaceous source system, but there might be a completely separate petroleum system below that. Tac is not a very large field. It's right there. Not very large by our standards here, is 15 kilometers long. So, seismic data, typical seismic data. This is off their website and in published domain. The upper part of the structure is all that's actually expressed in the seismic data. You can see it's an upright, fairly symmetric structure with some internal faults. And we know now, because of the orientations of those limbs and their relative lengths and everything, that it's a structure that's sitting on top of one of the detachment surfaces in the whole system. A flat in the fault network rides underneath it and pops it up, just like I call them magic carpet folds. And that presumably is being carried forward toward the south. You know, in one of their 3D perspectives, really simple anticlines. But they're usually misinterpreted because their relationships to faults are usually not fully recognized. If you don't recognize this detachment surface, you might go down and try to get a reservoir down below. And you'll find that you go across a completely different boundary, and everything down there is either in a completely different orientation, deformed in a separate structure and cut across by this detachment fold, or it's flat. The seismic data is deceptive because all of these structures are very angular. They're mostly variations on box folds, and seismic data doesn't really show that very well. So you'll see the structures being drawn this way. There's very little accurate migration done in a lot of these fields yet. Most of them are PSTM at most. People are just starting to do 3Ds and do PSTM migrations. Reservoir character, vuggy, fracture-related production. This stuff is all about, I think about, did they say on there, API? Yeah. Some of it's as high as 42, but the Eocene reservoirs are down at 24 or so. On the thin section character, you can see that the porosity is just chock-a-block full of oil. Large volumes. Here's some oil that's even salvaged along some stylites. The production is very variable. Usually they have to depend on fractures. I don't know if anybody has applied fracking techniques yet, but almost without question, procedure is to acidize the carbonate reservoirs, and they flow that way. In fact, Shaikan didn't flow at all until it was acidized, particularly in the upper reservoirs. So production is tough, the interpretation is tough, and drilling the wells is tough because they usually don't get a great prognosis because the seismic data is not handled correctly in a lot of cases. So here's an example from TAC where they've done the reservoir kind of characteristics. That Cretaceous reservoir is all three of these units. This Kamchuga formation is in places is a massive dolomite section, and then the Cometan is a vuggy limestone. The Shironish tends to be a fine-grained, very uniformly bedded, marly kind of unit, fracture dependent, and then various units with vugular kind of storage capacities.
Structural style.
All right, structural style. Let's see how we go. Like I said earlier, they're dip panel or pseudo boxfold geometries, and they don't image very well in the seismic data. Because of the angularity of a lot of the fold closures, they're mistaken for faults. And so the interpretations commonly have faults where they're not. And when you drill the well, of course, one of the things you really want to tell the engineers is where they're going to cross the faults. So a lot of times the wells turn out to be expensive because they have to set casing before they want to, or before they had planned to. And one of the difficulties here is you're way away from any kind of logistics. So you can't call up Houston and say, hey, deliver us some new casing tomorrow. So there's a lot of cases where wells have failed because they've been located poorly, or the wells have gone way over budget or had to be sidetracked because they've run into things that weren't prognosed. The folds are dominated by flexural slip processes, and that's basically just your notebook kind of thing with the pages of your notebook sliding past each other. Sounds simple, but there are a lot of complications, and I'll show you a couple. They're often asymmetric, and sometimes they're bivergent. In other words, their steep side is on the wrong northern side. And that's, as far as I understand from doing modeling, that's largely a function of the shape of the ramp that they're above. They tend to have a northern side steep when the ramp is actually curved, and they'll have a southern side steep when the ramp is like Suppian them like to draw it as a planar surface. They're very often complicated by secondary internal thrust sheets or thrust faults, things that are, rather than related to the generation of the fold, they're the product of the fold. I like to call them fold accommodation faults that allow the structures to tighten up, because this stratigraphy is a whole sequence of very strong carbonate units. You can imagine what happens when you take a piece of cardboard and you try to fold it. Breaks into two panels, right? And that's what's happening internal to the structure, and each one of those layers can break at a different place. There are, particularly in the north where we've been working, opposite Turkey, there are noticeable fault-controlled variations in the tertiary thickness. The tertiary before and during that Pelaspi section in the lower, in Paleogene, before the convergence. And those are a sequence of normal faults that have accommodated thickening section as the foreland basin has migrated to the south before the collision really happens, during the rollover. And they can be substantial. In places we've got like 1,000 meters of Eocene shales that thin down to 30 meters in other places. Those are commonly inverted during the process of the folding, and so we get these structures where we have big hanging walls full with giant wads of Eocene shale that are not anticipated in the drill core. You ran into one company ran into the situation where they didn't have enough casing to reach past the Eocene shales. And finally, they're very young. As we said, the growth primarily in the Neogene, and because of the climate, they're very shallowly dissected. So they look superficially very simple. But when you get into them, they're as complicated as any other fold and thrust belt. And here's the mechanical stratigraphy that's responsible for that. We were able to convert some of the elastic properties of the section into what we called a modulus-based mechanical stratigraphy. This was some work with Ron Nelson, who was on one of our projects. And then based on field work and seismic that I've seen around, here's the setup of the major and minor detachments in the whole structure. And of course, it's peeled off basement in most places on the front. And as you get farther back in the belt, that dives into the basement and brings up pieces of the Turkish basement to the north. Now, I'm speaking mostly about this northern area, and these vary a little bit as you go up and down the belt because of the stratigraphic complexity, but it's primarily the same kind of system as you get farther to the south. So the major ones I put in with red detachment surfaces at basement, and then here in the early Triassic. This is a major one that uplifts a good part of this section and allows the Paleozoic to interdigitate down below it, and I'll illustrate that in a minute. Right here in the source interval, which is so common in fold and thrust belts that the source rocks end up being the detachment surface because they generally weak type lithologies. But there are anhydritic units all throughout the section, so there are minor detachments throughout the whole section. And when I say detachment, this is horizons where the thin-skin fold and thrust belt has predominant, or has selected these horizons to be stratigraphic parallel thrust faults, which we don't, of course, see directly on seismic data. So this is the traditional structural portrayal of the Zagros fold belt, and you'll commonly see this in all kinds of promotional literature. I don't want to single these guys out because I think they meant it mostly as a cartoon. Petroceltic knows better than this is. This is the case. But you'll see these simple sled runner kinds of structures that are drawn and showing very simple folds. And oftentimes, particularly with regard to the Zagros, you'll see these go down into basement, and you'll see the folds actually cored by slices of basement. And that led to, and it's all covered by that foreland basin section, so all you really see in the old days without seismic data is the top of these. And they appear to be nice, simple, whaleback kind of folds. People would project them to depth and just do a simple sinusoidal thing. And they developed a terminology for the architecture of the belt. Out in front, you'd see the simply folded belt, where you just see the backs of these things. And then you'd get into an imbricate zone, where they're showing the faults actually reaching the surface. Well, what they're actually seeing that reaches the surface is a lot of those secondary structures that are related to the tightening of the anticline rather than the actual fold and thrust belt driving kinds of faults. And then you get into the high Zagros across the main and the central thrust, where you bring in these exotic type of lithologies. The ophiolites are placed on top of there, pieces of island arcs, all sorts of strange units that have nothing to do with the stratigraphy in front of them, except that they have supplied detritus into the foreland basin. You'll even see, it's very common, not to recognize that the main thrust or that the Zagros architecture actually doesn't stop. And so you'll see maps that try to continue a central thrust, as it's called over there, all the way up into this northern region, whereas, I mean, this has got completely different events. In order to do that, you've got to have that thrust bring oceanic stuff that's entirely exotic up on the same fault as stuff that's in the basement over here. So the structural geology is usually very, very much oversimplified. The modern view is starting to come out. Here's some sections that were drawn by Julia McQuarrie, and this is down in the Iranian sector. She did this for a PhD, I think at Stanford, if I remember right. And it's published in Tectonophysics, but I've just grabbed it out to show what some of the modern thinking is, that there are basement slices brought up in the core of the fold belt, and they're detached the stratigraphy from the Arabian plate, and that runs within the stratigraphy and ramps forward. And she has actually, restored some of these sections. People say, well, but what about the earthquakes in the basement? There are earthquakes all over the Arabian plate, and they're mostly at deep crustal or even mantle levels. And what's really happening, this is just a typical orogenic belt, is that the basement gets flexed as the orogenic belt gets placed on it, and a lot of those earthquakes down in the crust are decoupled from what you see at the surface. So you see a thrust system at the surface, and as you get deeper, if you were to look at a lot of the focal mechanisms for those, you would find that they are actually strike slip. They're a decoupled system, and they're strike slip because of the inversion, the flipping of the maximum principal stress that's vertical with time. So, in that sort of vein, if you were to look at some of the, and this needs a little bit of revision, it's a couple of years old, if you were to look at the productive horizons in various fields, as you go from inside the metamorphic belt here at the boundary, you find that the reservoirs are confined to parts of the stratigraphy that are in the hanging wall for the thin-skin fold and thrust belt. And that this system, of course, starts out back here and it inches forward the same way that, well, maybe you don't, but that I push a snow shovel in my driveway and accumulate a fold and thrust belt in the front of it as I push the stratigraphy ahead. So most of the discoveries out in front are in shallower horizons than the ones in back because these have been thrust up higher where there's a lot more shortening. If you look at Julie's section, you can see that the shortening out in these structures out in the front, which are just starting to develop, have a lot smaller values than the ones in back, and that a lot older stratigraphy is at the surface in the back. So if we look at particularly the northern part of Kurdistan here, and this is the part that we've been working in, you can draw a buried thrust front through here that includes things like Kirkuk, and somebody mentioned Bardarash. Bardarash is sitting right on this thrust front here. Out in front, here's the city of Mosul, and right in here is that reservoir that they were fighting over last year, right in there. Here's Shaikan, several of the other, Atrush, and several of the other discoveries, Swaratika back in here. Everything in front of that red line, which is the mountain front, is actually buried in what's relatively flat foreland basin sections with an occasional anticline popping up through it, usually right at the front. Now out in front to the south and west of Mosul is this thing called the Mosul High, which is well imaged on seismic data. It's very much well known that it's basement involved, and it's rimmed by a whole bunch of little anticlines. The stratigraphy on the Mosul High shows that it is a very long-standing high block in the Arabian Plate, and it shows various degrees of thinning during times, all the way back to the Triassic. But it is reactivated during this collision as a foreland basement block uplift. And it's got a bunch of structures around it, some of which have small oil fields. And the best model for that would be the Wyoming basement block uplifts, although the Wyoming ones are far more dramatic for various reasons. So with that kind of geometry or interpretation of it, the box folds show up at the surface. Here's a typical kind of shape of the anticlines. This one drawn as a ramp, flat, fault bend fold. You can see that most of the anticlines have dipping sections that very abruptly change the dip magnitude. This is on the front of Shaikan. This one is out of the city of Dohuk, and I guess that diagram doesn't show very well, but it's flat on top, and the stratigraphy, the very same stratigraphy, is standing right on end here. And this is out in that foreland with this cliff here and this riverbed is all, if you walked up to it, you would see it's made out of these cobbles of limestone, all derived from these limestones that are thrust up in the anticlines. But you can see the dip panel on the front, and they all get very flat on top. The flexural slip geometries that are complicating is, here's a surface map that was drawn for Shaikan anticline, and you can see the actual fold closures in different places are drawn with the pink anticlinal and synclinal closures, and I've drawn with these sort of symbols the dip panels. So on the north side here, on top it dips fairly shallowly and then abruptly goes to very steeper dips, and that's what that means. So here's the flat top going both ways, and then steeply dipping and then shallowing out, and then shallowing and then going steep. So the anticlines do these kinds of geometries. You can see that the closures are not continuous as you go along in detail. This is on the Pulaski limestone up in the Eocene, but we were studying that to get an idea of the structural geometry at depth. And this is something that you can get on the web that shows, they're trying to show the development plan, but it's very clever in the sense that it shows where some of the secondary thrust faults are actually cutting those two limbs, and you can see that they're not connected. They're not the faults that are responsible for the anticline. They're the faults that are responsible for some of these dip panel changes. And so if you look at it in a cartoon format in 2D data, you'll get these dip panels with various kinds of steep and shallow components to the fold, which are all related to usually to some detachment surfaces at some of these secondary thrust levels. And here I've just drawn one that's in the Cretaceous, and it pops up a little peak on top of Shaikan anticline. When they drilled, they spud it up here, and they started to drift this way, and they almost decided to step back and sidetrack because they thought they were getting off the closure. But they kept going. Had they stepped back and sidetracked, they would have sidetracked right into the upright limb, rather than actually made the discovery down in here. If you look at that kind of a geometry in the 3 dimensions, here I've drawn a perspective diagram on it, and this orange surface here is the fault. So that red line, is this fault. As you go down strike, it offsets the closure because some of those faults are actually connected together by what we call lateral ramps, which are crossing the bedding. They run in bedding and they connect to steps, if you like, that cross the bedding, and then connect to another bedding plane fault, and they may even tip out and not even get to the surface. And that's because the flexural slip is accommodating differential displacement as the fault grows and is shoved from north to south. This distance is on the order of 20 kilometers. So at depth, of course, that segments the reservoir. And that's the potential always to be the danger. These things can be seen in seismic data. There's one piece I'll pirate from GKP just to illustrate it. This is a strike line on the south flank of the Shaikan anticline. And you can see you run along on one of the segments, and then all of a sudden you hit a step. And you've got to jump up or down, because you've got to remember that those beds are tipping either toward or away from you, and they have different dips. So these confusing relationships are related to the fact that you're not seeing a flat stratigraphy and you're not seeing a true thickness. But this is that step, that lateral ramp along the axis of the structure. So you're going along here, and then all of a sudden you got to cross that and get into another lobe of the structure. These are often called tear faults, but notice that they do not cross the entire structure. You might just cut one limb, and you might find another one on the other side over here. So depending on where your reservoir is, this can be a compartmentalization feature, or it can be a hazard to drilling, or it can be a risk factor in the integrity of the reservoir. All right, enough hobby horsing. On a bigger scale, the mountain front is also structurally segmented. And here's a map from Geologic Data Systems that John Ferguson up in Denver lent me. It's out of their GIS compilation of all the mapping in the area, and he was kind enough to color 2 particular units for me. In blue, he's colored the outcrop of that Pulaski limestone. You can see it forms this big snaky thing here and surrounds all these structures, and then turns up again there. This valley up in here is where the Fars Formation is, that polymixed basement involved pebble assemblage lying right above the Pulaski, and then out here is where the Fars is the standard Fars that you would read about in the literature. You go farther down strike, you'll see that the Pulaski the red is the Jerkus. It's that Eocene shaly unit that varies in thickness so much. So that's the inversion section just immediately before the foreland basin section swamped the whole margin. And you can see it pops up, the Pulaski pops up in some of these. This is Barter Ash down here. And then down at Piermont, we've got another situation where these folds stand out from the main mountain front, and they're rimmed and expose extensive outcrops of the Pulaski limestone. So there are these different segments along the belt, and I've drawn a couple of cartoonish interpretations of that. In that aqua recess, or this embayment in here, if you were to do a balanced section or a restorable section back into the mountains, you would find that you saw something that looks pretty normal in terms of our overthrust types of geometries. In this particular case, we've got primarily fault propagation structures, but they all gather into a detachment that's down deep in the section, and by the time you get to the mountain front or inside the mountain front, it's now running in that major detachment at the top of the Paleozoic, that one that's in the Permo-Triassic. If you go farther to the northwest, where the outcrops are a lot farther to the south, they've been uplifted a lot more dramatically to do that. And the best interpretation here, based on, and I'll show you one of the sections, is that in this particular part of the fold belt, that geometry, that standard kind of familiar overthrust geometry, has actually been underthrust by another geometry, one that actually goes down to that basal detachment surface, down near basement, and it forms a duplex of slices of the Paleozoic, perhaps maybe a few pieces of basement as well, we don't really know. But it uplifts this package of post-Permian section into a lot of the discoveries. All four of these are discoveries. That's the 10 billion barrel one. And they've all been drilled down to that Permian level without any indication that there's much of this overthrusting going on. So these are deformed a little bit. They got some minor folds in them. You can see here's one of the inversion structures. And it's all been uplifted a little farther by a deeper detachment. Now, when you get back into this aqua recess, if you go back farther into the mountain range, you start to find out that that geometry is effective up farther to the north even. So the sequence of events that I've put together is that there's an early detachment surface, probably in the Jurassic, in some places probably ramping down to that Permian, and then it's been undercut by the younger, deeper thrust system that's uplifted the section. Here are a number of simplified wedge geometry kind of approaches. Here's the one for the Dohuk passive roof, and here's that aqua recess. And what I've drawn on here is the position of basement, including some positions here where it's been thrust up into the belt, and the Pulaski limestone relative to sea level. So you can see that Pulaski limestone has to have been uplifted in certain parts of the belt way above sea level, and of course it's a sea level deposit. So in a lot of places it's been lifted as much as a kilometer or two above its regional depositional pattern. The way to do that is by this thing in the thrust wedge geometry these days that people call passive roof. And this is the basic idea that with the development of a duplex by forward imbrication or stacking of thrust slices, that you uplift in a kind of a passive way everything that's above the roof thrust that allows those to interdigitate. So you start out with a ramp anticline, and if erosion doesn't take your upper part of the section off, you end up with a uniform stratigraphy going over the top. And then it collapses again, generates another thrust slice underneath, and so you end up with a stack of these. Now ordinarily in most fold and thrust belts that we are familiar with, that's all been eroded away. You've lost the passive roof. And you'll see in places like the Canadian Rockies that there's a triangle zone out in front like this that has that back thrust. And that all of that is lost to topography, is lost to erosion, and you get imbricates that come to the surface, which is the familiar thing we have for fold and thrust belts. Because the level of exposure in a normal fold and thrust belt is pretty deep. Not so in a young fold and thrust belt with almost no weather. In this climate, there's very little erosion of the fold and thrust belt except way in the back. So you start to develop this passive roof, and you can even start to develop faults cut through it. Now what I did for this slide was take a picture from Zhu and Zhao in the 2000 AAPG bulletin that was drawn for fold and thrust belts in Central Asia. And they've got probably the best seismic data that shows the preservation of this passive roof. And you can see that the net effect of the passive roof is that there's very little shortening in it, but a lot of uplift. And that's what we see with that Pulaski limestone. So here's the interpretation of the Doe Hook passive roof with a couple pieces of seismic. You can see that the anticlines themselves are deceptively simple. There aren't a lot of connections between, a lot of thrust faults that affect it. Certainly not enough thrust faults to build up that topography. So the interpretation is that there is an older, less dramatic fold and thrust belt, partly inverting some of the old normal faults, and it has a passive roof in this part of the section, and that the secondary development of the structure to get the uplift and to get the sense of urgence on some of them is to have a duplex developed underneath that actually reactivates that frontal thrust and redeforms some of the structures that people find deceptively difficult at depth. And if you go up and down the belt, there's 2 or 3 places where you can see this. This one that I've called the Doe Hook passive roof, and then the Piermont passive roof, and there's another one down here, the Binabawi passive roof. Once you get your eye out for them, all you got to do is map that Pulaski limestone and look where it sticks out from the front of the range. All right. So much for those. Now the youth of the section, and this is the last point really, is the fact that this syntectonic deposition is preserved and it's still quite complicated. Here's a picture of the mountain front. This is actually the Cretaceous limestone coming up, and that's the Pulaski limestone. And this little 100-meter wide dip panel of the Jerkis Formation, that Paleogene shale unit, is standing right up on end. And it's cross-cut by a number of unconformities. Here's the Pulaski limestone. Here's the upper fires and the lower Bakhtiari sandstone, standing right on end with that same structure, and then cross-cut by the upper Bakhtiari conglomerates, which are these, sitting right on top of the angular unconformity. And then that's cut by modern valley fill conglomerates, which are some of which are perched on the sides and re-eroded through by the current valleys. And then the whole thing is topped by a pediment, which typically dips about 3 degrees toward the south away from the mountain. And like I say, has a nice pediment veneer or terrace veneer. So the fold belt is buried in its own debris, and only at the mountain front is a lot of that removed, and yet it's preserved in a lot of the synclines as you go back into the belt. So it's very shallowly eroded, and hence we only see the top, and that's why it gets to be deceptive. Here's that pebble surface for the pediment. We're right out in that aqua recess area. These terraces are the pediment surfaces. If you go around the edge of this terrace, you get off the boulders and you go down into the fires in the Bakhtiari Formation, and you get up on top. It's only about 5 meters thick, and it just forms a terrace level, and as you get in the back there, you can't really see it. It really requires some more field work, but it's a really important geologic problem. Is that pediment actually being folded? Because that would imply that since the Pleistocene, there's been a component of deformation in a lot of these frontal folds. All right, enough of my hobby horse. Conclusion, summary from the geologic summary, or the geologic issues. Arabian Plate, world-class multiple petroleum systems. It's easier to find something that doesn't participate than something that does. Very few units, some specific units are not participating. Otherwise, just about everything somehow is involved. They're dominantly but not exclusively carbonate reservoirs. There are some clastic reservoirs, but they tend to be the subsidiary ones. And so they're typical Arabian plate, fractured carbonate, buggy reservoirs with all of the hairs that those have on production. There's subtle, complex stratigraphic control on the reservoirs because of that very complex stratigraphy, that long period of time being peripherally affected by tectonic events around it and by sea level fluctuations. So that in any one particular structure, you really can't predict what you're going to get. And finally, the fold and thrust belt is a true thin-skinned fold and thrust belt where the discoveries are being made with all the structural complexities that are involved. And the conventional wisdom, the simple old 1950s and 40s Zagros terminology is kind of obsolete. And it handicaps operators if they start to think in those terms.
So what about the future?
So what about the future? We're seeing the beginning of a very interesting, very prolific province if. Will the birth of the ISIS caliphate see an early death? Or have we got complex strife back and forth in the area the whole time? They are very close to that exit pipeline. And all we have to do is have the war front move back and forth, and we can have major disruption. Last year, as ISIS swept to the south, all the operators continued working. In fact, I was there in June when they were fighting over the refinery down to the south. And everybody continued to work. But then ISIS started to focus their attention in the north. And you'll remember there were those initial battles that the Peshmerga lost. All the operators pulled their people out. And then as the Peshmerga started to gather steam and get control of the situation, all the operators came back in. So any sort of reversal of fortune in any of this can completely change the situation. And then when it's over, can the central government and the KRG live together? When it looked like Baghdad was going to fall, with ISIS sweeping to the south, everybody in the KRG was saying, independence, independence. And of course, most of the world does not want to see that, but it could happen de jure because it's actually de facto right now. The Kurds operate more or less independently. What's the future of Turkey? We see the Prime Minister of Turkey tilting toward more Islamic tendencies lately. But on the other hand, they've been making progress in solving or at least settling their Kurdish situation. There have been various agreements over the last few years that kind of put the PKK out of business. They're tolerated along the border, on the south side of the border right now, but the KRG won't let them do very much if they start to actually mess with the Iraqi Kurdish population. So if they can be quelled and Turkey can continue its relationship with the West, that plus U.S. patronage is basically the key to Kurdish independence. Being landlocked, that pipeline out through Turkey is their only lifeline. If they break up with Iraq, that's not going to be a happy situation. It's not a happy situation even if they live together. Syria is not an option right now, and certainly Iran is not an option. So looking again at Iran, what is the future of Iranian and greater Arab relationships in the area? What's going to be the outcome of the current discussions about Iranian militarism? Is that going to lead to some kind of better regional cooperation? All of these things are going to affect the Kurdish success. And hopefully, my personal inclination is that I hope the U.S. tilts more toward the Kurds and supplies them with modern equipment, modern industrial things, so that they can develop their stronger independence. All the world has been reluctant to do that because the U.S. has been committed to the federal Iraqi government. And the federal Iraqi government doesn't want strong Kurdish independence. The Turks have always been reluctant to supply the Iraqi side of Kurdistan because it might strengthen their own Turkish minorities' rebellions. So the poor Kurds have been sitting there intellectually and socially and everything. We have better connection to them than we do to most of the other populations in the Mideast, but because of geopolitical situations, we have to, I would call it neglect them. Anyway, I might add that the KRG is the only friend of Israel in the Middle East. They have, one of the ways they've gotten their oil out is to sell it through Ceyhan, sneak it into tankers, and some of it's been delivered to Israel. And you might have seen in the news over the months that nobody wants the KRG to actually be paid for any of this oil because it's supposed to go through Iraq. So tankers have been floating around out there trying to find somebody to buy the oil because Iraq has, and the U.S. have threatened to bring lawsuits with regard to anybody that's buying the oil. They regard it as contraband. So that's slowly getting better. Some pretty serious talks have been between Baghdad and the KRG recently to allow them to get funds that way. And that's in Baghdad's interest, because if the Kurds decide that they're really not going to support Baghdad in their Sunni Shia fight down there, it's one thing that the Iraqis lose. So with that, I think I've gone way too long. Sorry to keep you. Thank you. I hope you found it interesting.
Thank you, Jim. I think because of the lateness of the hour, if you have any questions, please come up and see Jim afterwards. I'd like to thank you, Jim, for giving the talk. And
Bring a beer.
yeah, petrified wood from the Yesenia Formation.
Oh, wow.
Texas. Very nice piece. Thank you very much.
Thank you.
very much.
Thank you, Scott.